And liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond. Drivers on a rated performance, reducing the stress on the shuttles and breaks through the sound barrier. The speed will already 3.5 miles and 750 miles an hour. Everything looking good. Solid rocket booster separation confirmed. Guidance now converging. Discovery's onboard computers commanding the main engine nozzles to swivel, aiming the shuttle.
1 minute now until touchdown. Discovery's landing gear will be locked down and into place at 300 feet in altitude. It's currently 3,500 feet and traveling at a rate of 370 miles per hour. Main gear, landing gear now down and locked. Main gear touchdown. Pilot Jim Dutton now deploying the drag chute. Nose gear touchdown.
Hello. I'm standing in the Space Gallery of the San Diego Air and Space Museum, and I'm standing next to a 1/25th scale model of the Space Shuttle. At the end of the Apollo program, the nation was faced with a difficult decision on how we should proceed with our space exploration. Should we continue on to Mars, or should we exploit low Earth orbit? The decision was made in January of 1972 by President Nixon, who decided we should build a reusable human spacecraft to explore low Earth orbit and ultimately to build a space station. The development of the space shuttle took about 9 years, from 1972 until its first flight in 1981. Let's take a look at the space shuttle. The space shuttle really is made up of 3 different components. We have the solid rocket boosters, which are the 2 white rockets on either side of what you see as the large orange tank in the center. That large orange tank is called the external tank, or the ET. And then we also have the orbiter itself, which is mounted on the side of the external tank. These 3 components were manufactured in different locations, but they all came together at the Kennedy Space Center, where they were integrated for launch. The solid rocket motors on either side of that large external tank were built by Morton Thiokol in Utah, and they were loaded with solid propellant there and shipped in segments by rail to the Kennedy Space Center. The large orange tank in the center, the external tank, was built by Lockheed Martin in Michoud, Louisiana. It was transported by barge around the Gulf of Mexico up the east coast of Florida to the Kennedy Space Center. And lastly, the orbiter itself was built in Palmdale, California, and it was transported actually by air, piggyback on a modified Boeing 747 across country, and also taken to the Kennedy Space Center for integration. The space shuttle amazingly has over 24,000 protective tiles on it to protect it against the heat of reentry. Each of those tiles happens to be unique, which is a hard thing to believe that there would be 24,000 different tiles, each their own shape. So the first space shuttle actually was Enterprise. A lot of people forget about this one because it never flew to space. It was used on approach and landing tests to give the astronauts some skill and proficiency in landing what essentially was a glider. There was only one chance to land the space shuttle because it had no engines on it to make another pass around if things weren't going exactly right. So during the 70s, during development, the Enterprise was carried aloft by the 747, separated, and then glided back to the dry lake beds at Edwards Air Force Base. Finally, the very first space shuttle was delivered to Kennedy Space Center. That was Columbia, and it was launched in April of 1981. What would a typical flight profile of a space shuttle look like? Well, as you can see, we have the 2 solid rocket motors, but at the aft end of the space shuttle are 3 main engines. they were fed by that large external tank in the center. Liquid hydrogen and liquid oxygen were the propellants. So at ignition, those three engines would come up to full power. When they checked out okay, the solid rocket boosters could be ignited because the solid rocket boosters could not be turned off, whereas the liquid engines on the space shuttle could if there were a problem. Once everything was okay, the space shuttle would lift off, and it was a short 8-minute ride to orbit. Now, everything didn't go to orbit. The solid rocket motors that are on each side of that large tank were separated at about 2 minutes. They would glide back under parachutes to the Atlantic Ocean, where they would be recovered and returned to the Kennedy Space Center. The segments would be separated and then loaded onto rail cars and sent back to Utah for refurbishment and reloading of propellant. So now, after 2 minutes, the next 6 minutes, we're using that external tank attached to the space shuttle orbiter to get to orbit. Almost. Because we didn't want to take that large external tank to orbit, it would separate just before orbital velocity was attained. So how did the space shuttle eventually make it to get to orbit those last few hundred feet per second? Well, there were two other rocket engines on either side of the tail of the space shuttle called OMS engines. OMS, OMS, standing for Orbital Maneuvering System. And those smaller rocket engines would provide that last little bit of velocity to get the orbiter into orbit. Those same rocket engines would also be used to decelerate the orbiter when it was time to come back home. Typical missions would last anywhere from 5 to 14 days. The longest mission was on the order of 17 days. And a number of different things would be accomplished while the space shuttle was in orbit. And there were quite a few firsts during the space shuttle's lengthy program. For example, it was the first time that we ever saw an astronaut do a spacewalk untethered, completely separated from the spacecraft. It was the first time we launched an American woman into space, Sally Ride. First launch of an African American, Guy Bluford. Many, many different spacecraft were launched from the space shuttle. Very famous, as most people would know, is the Hubble Space Telescope, which opened up all kinds of new discoveries in astronomy. We launched the first spacecraft to orbit the planet Jupiter from the space shuttle, Galileo. Magellan, the first spacecraft to map the entire planet Venus, was launched from the space shuttle. And of course, the reason that the space shuttle was built in the first place, to help us build the space station. The cargo bay was 15 feet in diameter and 60 feet long, and was really purpose-built to carry large payloads. The orbiter itself was on the order of 230,000 pounds, and it could carry payloads on the order of 50 to 55,000 pounds. Without the shuttle, the International Space Station would never have been built. So we ended up building 6 space shuttles. I already mentioned Enterprise and Columbia being the first. After Columbia came Challenger, and then there was Discovery, Atlantis, and Endeavour. Endeavour was never really meant to be built, but when we lost the Space Shuttle Challenger in that famous accident in January of 1986, the Endeavour was built as a replacement. And then sadly, in 2003, we lost the Space Shuttle Columbia on re-entry to Earth. We hope to see you soon at the San Diego Air and Space Museum.